that was funny. And then it builds a little more and you go, oh my goodness sakes, this is really funny. I feel really happy now. And then it keeps augmenting more and more of your own endogenous cannabinoids, preventing them from being inactivated, and you release more. And it's just this positive feedback cascade until you are full-blown hallucinating high.
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 168th episode of this podcast dedicated to the ongoing betterment of your brain by any and all means at your disposal. This is an episode where we are going to lob some very against-the-grain ideas at you, things that sound almost like oxymorons on the face of them. Example, that marijuana might actually be good for your memory, and as if that wasn't weird enough, that exercise might make you die sooner. Where is all this coming from? It's coming from a conversation with Dr. Gary Wenk of Ohio State University, a researcher who is following his curiosity into strange and unexpected places, has done some very interesting rodent research, which he'll be telling us about and how it might apply to humans. A lot of mights here, a lot of speculation, things we're not sure about yet, but the evidence is pointing in interesting directions, and we'll be talking all about that in the main interview. If you hang around until the very end of the episode, so it's just past Valentine's Day now, but in case you haven't gotten quite all the Valentines out of your system, or you're still thinking romantic thoughts, in the Ruthless Listener Retention Gimmick, I'm going to tell you what some science seems to be showing is the key feature in your attractiveness to another person. It's not the length of your eyelashes, it's not how you look in those jeans, but it's something that you'll hear and say, oh yeah, that kind of makes sense, and it's worth waiting around for. That'll be at the very end. But right now, let's kick things off as usual with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So my mom is in her early 60s, and she says that looking back over the course of her life, she sees there having been 5 different versions of her sequentially going through the ages from being a little kid up until the woman that she is now. Obviously, these weren't entirely distinct where the curtain would close on one and open on another and it's a new act, but looking at it retrospectively, she sees 5 separate women who sequentially led to where she is today. I've always thought this was kind of an interesting concept, and I was reminded of this when looking at a recent study published in Psychology and Aging, which is looking at the longest running personality test that has ever been done, apparently. The earliest part of this data was grabbed in 1947 as part of the Scottish Mental Survey, when 1,208 students were rated on 6 personality characteristics by their teachers when they were around the age of 14. These same students were also given intelligence tests at the time, and subsequently, although some of these people they lost touch with, others died, researchers tried to follow up with them over the years and decades, and most recently, in 2012, researchers were still able to track down 635 of the one-time teenagers, and 174 of them, now aged around 77, agreed to take part in a new round of testing. They tried to test as closely as possible for these 6 markers of personality, both self-assessments from the people themselves, and also assessments from people who knew these research subjects well and were nominated by the research subjects as, yeah, this person really knows me, they know my personality, and were sort of stand-ins in the assessor role for what their teachers would have done when these people were 14 years old. And other studies that have looked at how personality changes over the course of a lifetime have found that things do change. The personality doesn't remain rock solid, but there's still a significant correlation between how somebody is as a child, how they are in adulthood, or how somebody is in middle adulthood, and how they wind up behaving as an elderly person. But this latest test, looking at a full sweep of 63 years from ages 14 to 77 for these people, surprised the researchers by finding really no statistically significant correlations in personality between the 14-year-old kids from 1947 and the 77-year-old senior citizens. Said researcher Matthew Harris from the University of Edinburgh, personality in older age may be quite different than personality in childhood. The 6 personality components that they tested on in 1947 were self-confidence, perseverance, stability of moods, conscientiousness, originality, and desire to learn. And the way that psychologists have modeled personality over the subsequent decades has changed quite a bit, but for this follow-up testing, they tried to match this earlier model as closely as possible. Thinking of some possible explanations for this rather surprising finding, researchers speculated that this could have been somewhat skewed by the fact that the group that they wound up studying at age 77 was a selected subgroup of the original sample. Less than a third of the people that they were able to find agreed to participate, and those who did had much higher average scores on dependability and intelligence than those who chose not to participate. So maybe that throws off the significance of the results somehow, but it's kind of hard to imagine that a group that is higher on the average level of dependability would have shown less consistency in their personality. So a thought-provoking finding: you really might not be the person you used to be.
Smart Drug Smarts, the podcast so smart, we have smart in our title twice.
Picked up a couple of 5-star reviews on iTunes. Listener Dr. Jackal from the USA says, I'm a modafinil prescribing doc who's always looking for new, better, and more creative ways to improve our physiology, and I've gleaned an abundance of information from your podcast. When I go on my daily canyon hikes near my home, your approximately 45-minute shows fit perfectly into my trek. Well, that sounds kind of awesome. I like the lifestyle that Dr. Jackal is describing. Cognitive enhancers and some good hikes. And Listen Me Lazy from Australia says, this is an amazing podcast, educational, interesting, entertaining, and Jesse will even have you listening until the end. Well, thanks to both of you. I will quit while I'm ahead there so we actually keep you listening until the end. Couple of reminders before we get into things. We've got a newsletter called The Brain Breakfast. If you're a newcomer to Smart Drug Smarts, you haven't discovered the podcast until fairly recently, we're wiring up a bit of a best of guided tour through some past episodes of the podcast for new signer-uppers to the newsletter list. We've also got a lot of links there to different things going on in the world of neuroscience, the kind of articles that we trawl through as we're looking for what we're going to make episodes out of. All this and more at smartdrugsmarts.com/newsletter. And also a little hat tip to our retail website, Axon Labs. That's online, not at axonlabs.com, but axonlabs.io, which is where you will find our supplement stacks, Nexus and Mitogen. I didn't take any Nexus today. I was kind of in a focus mode, but Mitogen is an almost daily supplement for me. Our mitochondrial enhancer, I pop a couple of those before any major workouts, and oftentimes just one to wake up in the morning with a little bit of black coffee. But that's got sulbuthiamine, idebenone, and a host of other good stuff. You will hear in the coming episode when Dr. Wenk talks about a rather astonishing amount of energy that your brain uses proportionally compared to the rest of your body. That energy is, of course, getting supplied indirectly by the power plants within each of our cells, the mitochondria. Your brain's got more than its fair share of those. So when you're doing a favor to your mitochondria, you are definitely helping your brain out as well. So is Mitogen a general health stack or a cognitive enhancer? I will let you be the judge, but you can find that over at axonlabs.io. And now let's move along to the main interview.
Smart Drug Smarts.
So I'm about to be speaking with Dr. Gary Wenk. He is a professor of psychology and neuroscience and molecular virology, immunology, and medical genetics at The Ohio State University and Medical Center. And he's one of the world's leading authorities on the consequences of chronic brain inflammation, which, as you can imagine, is not a good thing, and also animal models of Alzheimer's disease, which is not an unrelated subject. He's also, you'll get the sense, not somebody that's intimidated by overturning the apple cart, saying that the emperor has no clothes, and probably being the first guy to cannonball into a swimming pool when the occasion warrants it. We're going to be talking largely in this interview about the potential therapeutic use of marijuana against brain inflammation and Alzheimer's disease models. Dr. Wenk's work is in rats, so the applicability of his studies to humans is subject to some speculation, but his findings are intriguing to say the least. He is also author of the past book, This Is Your Brain on Food, and is definitely a believer that the linguistic lines we draw between food and drugs is probably far too black and white, and that this really is a very sort of gray, fuzzy line that we should think of more in that way. And he's got a new book coming out in just a couple of weeks called The Brain, What Everyone Needs to Know. So this conversation will be a little bit of a preview for that book, but also an overview of Gary Wenk's recent work and overall career. So with no further preamble, Dr. Gary Wenk.
You know, we were looking around for an effective drug that would be a nice, safe anti-inflammatory, and we knew that marijuana had anti-inflammatory properties, you know, sort of along the line of Advil and aspirin. And then about the same time, it was discovered that Tylenol is actually converted into a marijuana-like molecule in the body. We never really understood how Tylenol worked, and I'd been trying it, and it was effective. And then we realized, oh, well, the human body's turning Tylenol into essentially a cannabinoid.
Wow.
Which raises interesting questions about whether it should be legal, but too late now. You know, I was looking at groups of people who suffer with pain and inflammation, which is something that we knew that marijuana was effective for. And what caught our attention was that these patients were claiming that they could just do one puff a day and their medications more effective, they said. They were in less pain and they could move more. And we thought we were intrigued by that because we knew what mechanisms underline what marijuana does. And we thought, well, let's follow this up. So we decided, you know, I study aging in rats, and we had to scale everything down to a puff a day in a rat, which is trial and error, of course. You're not going to have them just sit in there with a joint in their cage. So we needed to have some control, but we managed to scale it down to something that might be the equivalent of just one puff. And, you know, how many people actually do that? Well, apparently the MS patients did, and it helped them. So to our great surprise and joy, that very low daily dose turned out to be very effective in our animal models, which raises the question, well, what is my animal a model of? Well, it's a model of things that happen to everyone because they're alive and breathing and eating. You develop some inflammation in the body and brain, we knew that people who were particularly obese had more inflammation in their body, and we were beginning to understand why obesity led to a lot of age-related disorders. And we were starting to put things together, but we needed a nice tool to sort of intervene.
Inflammation we think of as being akin to swelling in a lot of cases, but also the brain shrinks as people age. And I'm just wondering how those two processes play off against one another.
That's a great question. The shrinkage is due to a loss of water, actually. It's a dehydration more than anything. We used to think that the brain lost lots of neurons, and it turns out that it doesn't really lose that many. But there is a lot of dehydration and shrinkage. And I've done a lot of autopsies on young and old people with young and old brains, and the difference is quite striking. And even in quite healthy people, if they're elderly, you still see that shrinkage. And I think you've touched on something critical here. I first got into studying inflammation in the brain over 20 years ago now. The reviewers of my grant proposal said, hey, come on, there's no inflammation in the brain. It's a protected region that had been dogma in textbooks forever. So they had to get beyond that. And the kind of inflammation that happens in the brain is similar to what happens in the rest of the body. And there are these inflammatory proteins. Some are helpful and some are dangerous. Inflammation produces what we call oxidative stress, which is just a byproduct of breathing. And I always get this question, what would I do every day that makes me get older?
Right.
Because clearly, the more days you've been alive, the older you are and the older you look. So what exactly am I doing every day? And the answer is very simple. You eat and breathe. And what we've discovered is that if you do much less of both of those things, you're going to live a lot longer. Everyone hates that advice. My TED Talk, I tried to push that story, and people say, well, why can't I just exercise it off? And I said, well, no, you missed a point. I said, I don't want you to be breathing in so much oxygen. It's all about not taking in the calories at all. What we've discovered now over and over again with single-cell organisms up to dogs, monkeys, humans, and everything is that the more calories we consume, the faster we age. That's what you're doing every day that makes you old. And eating and breathing produces inflammation, oxidative stress. So what we've sort of stumbled onto as we try and find ways to prevent aging is that some people don't seem to age that fast. And when you interview them and say, sir, you're 85 and you're not demented, what did you do differently? And they started telling us things. This is just like the example with MS. We started learning things that people did that they claim kept them young. And one of those was that, I drank a lot of alcohol and or I smoked marijuana or I smoked cigarettes, whatever it was. And it was usually immoral or illegal.
Right.
Or I drank a lot of coffee. So believe it or not, the past 15 years, that's what my lab's been following up on. So we looked at high coffee and we looked at caffeine doses and we looked at nicotine and cigarette smoke components and marijuana. And it turns out that these people aren't making this stuff up. We now believe we age a little every day. So if you do something a little bit every day that slows your aging, like don't take in so many calories or expose your body to wonderful anti-inflammatories, then you age more slowly. And so what's the advice? People tell you eat lots of colorful fruits and vegetables. And it's like, really? That's it? Well, it turns out it's the color in the grapes and the raspberries and strawberries and the vegetables. That color tells you it's going to absorb the oxidative byproducts of breathing. So if you eat more of those things, you're going to be protected from that constant behavior of yours of eating every day and breathing. This is why you get this obvious advice, fruits and vegetables, colorful things on your plate. This is what mom tells people. And there's a reason. We understand the mechanisms now. But if you don't listen to mom and you eat bad food and you have a lot of brain inflammation, we're discovering that there are some things like 6 cups of coffee every day or a puff of marijuana or things like that seem to be beneficial. So what I'm saying then is that there are ways from looking at the epidemiological stories that we get from people of slowing the aging process. What I'm not talking about is preventing aging. We can't do that. We're also not saying, look, if you start developing the symptoms of Alzheimer's disease, smoking a puff a day is not going to help, and it might make things worse for your caregiver. And that's an important distinction. Let me give you what we know better. About 40 years ago, it was discovered that people with arthritis tend not to get Alzheimer's. Well, people with arthritis take a lot of anti-inflammatories, and that led to some insights. Well, they're taking all those drugs, and that's what's protecting them. Could they have smoked a bunch of marijuana every day? Would it have been just as effective? Probably. But we don't have that epidemiology. But when we understand the mechanisms, we begin to then sort of go back and ask people, did you do this? And did you benefit from it? We discovered about 20 years ago that people who drink a lot of coffee, like 5-6 cups a day, don't get Alzheimer's disease. And it's all about the caffeine. Coffee's got a lot of neat things in it that are very healthy, but it's the caffeine. So when you start scratching the surface of the stories that old people tell you, you discover these little gems that we can then go into the lab and unpack the mechanisms and say, hey, this is something we could do here that could actually have a benefit. This is what we learn from talking to people, is that sometimes it's anecdotal, no cause and effect, and other times if you follow up, you learn a lot, and maybe that allows us, we hope, to design better drugs. And that's where I got into cannabinoid research. Cannabinoids cross the blood-brain barrier. They're very potent, they're easy to administer, and they're very safe in, the way we can administer them, edibles and vaping and so forth, relatively safe, of course. And it's something, a low dose that somebody could do every day. But, this is an important caveat. What we found is that it's a nice way to get rid of brain inflammation. But you need to keep in mind, this is one of the studies I published a few years ago, the way that marijuana interacts in the brain, those protein receptors are in young brains, they're in middle-aged brains, they're in old brains. So it matters when you're smoking. What we found is that young animals, just like young humans, should not be bathing their brain in marijuana. It's bad. It interferes with normal development and function. It has negative consequences. So I frequently have people writing me saying, should I start, when I'm 16 or 18? And it's like, no,
right.
No, the epidemiology isn't like that. But now that we understand what's going on, we realize this is an intervention maybe in middle age, and when, ironically enough, most people don't smoke marijuana.
For people that don't have much of a basis here, like how much is a puff a day? Is a puff a day going to have psychological effects? Or I guess if you get the right kind of marijuana, it might only have physical effects rather than something which is going to space you out at all.
That's an important question, and that was where my research has been headed for a while. How low can you go? Currently, we worked our way down to about a puff a day. Now, that's a rough estimate, isn't it? Because, how much is in that puff? And
right.
We measured the levels in the animal's blood, but scaling it up to humans is not an easy thing to do. And I've had some of my undergraduates try this. They told me that after 2 or 3 weeks, they do tend to feel a little high. They notice it's in their body. Keep in mind, there's a big fat sink in our bodies. Marijuana likes to just live in our fat, and it will hide there from metabolizing enzymes. And so it will build up over time. So yes, this is something, probably you want to go as low a dose as possible. We envision something like a patch that would be very, very low. We don't know what low enough means yet, because quite frankly, haven't done enough research to answer that question. But what age you start does matter. There's nothing about what we understand today that would lead me to believe or predict that one of the designer cannabinoid products would be any better than the original, the thing you found out there, the cannabis, sativa, indica, whatever. Because what we've discovered is it's an aggregate effect. It's not one molecule. I keep hearing about CBD. It's a cannabinoid-like alkaloid in the plant. Everybody's excited about it because it isn't psychoactive. Well, it's not psychoactive because it's 1,000 times less potent, meaning it is 1,000 times less able to interact with marijuana proteins in your brain than is THC. That's all that means. So if you were to sit down and smoke 1,000 CBD cannabidiol cigarettes, would you get high? Sure. But nobody's going to do that.
Right.
It is a completely innocuous molecule. There are at least 60 alkaloids, cannabinoid products this plant makes. Not for our benefit, of course, for its own benefit to kill bugs and insects, whatever. And many of them are just precursors to THCs or byproducts of THC. The plant doesn't care. And one of them, actually many of them, have no actions in our brain or bodies at all. CBD is one of them. So all this stuff you've heard about CBD and seizures is an absolute myth. Only children in Colorado who go there and benefit from CBD are the ones whose parents bring them to Colorado. Little kids who live in Colorado have never shown any benefits from CBD. It's totally placebo on the parents' benefit.
We've been talking about inhaled marijuana. Is it equally valid to assume that this might work through a patch or this might work through edibles, or have the studies been done there to look at it one way or the other?
Well, none of the studies have ever been done on humans to answer that question. Keep in mind, it's all anecdotal. The reason we have no data is because it's a Schedule 1 drug.
Right.
We will never have data as long as it's a Schedule 1. All we have are what I can offer, rodent research, and it has its strengths and weaknesses. So I can look at the mechanisms. We know how to compare with humans in some ways, but to say that we have evidence that it actually prevents Alzheimer's, no, nothing like that. Epidemiologically, we can find correlations, but correlations are not cause and effect. So it's very frustrating. I personally feel that any age-related disease or even disease of adulthood where there is pain and inflammation, cannabinoid therapies will be very effective. But we have no evidence in humans to prove that yet.
How do you go about testing the actual inflammation in your rodents, like the timeline between when you start applying one of these therapies and being able to see a result? And how are you looking at those results?
Great question. Now, that gets down to the mechanisms of what we think underlie brain inflammation, but essentially begins with the fact that we are a balance of bugs. There's about 1.5 as many of them in us as we have human cells. So we're full of bugs, and those bugs die all the time. And the byproducts of those bugs dying produces inflammation in our bodies and brain that our immune system defends us from all day long. Let's pause and think about that for a moment. You have about 4 to 5 pounds of bacteria in your gut right now, and they are dividing thanks to the food you're giving them constantly. So you always have to ask the question, why on earth at the end of a 24-hour period isn't my stomach the size of a beach ball?
Right.
So somebody's killing them. Well, in with all those bacteria are tens of thousands of times more viruses that kill them. So now the question becomes, where's all the dead bodies? And the answer is that 60% of the dry weight of your fecal matter are dead bugs. If you ever wonder what was in there, that's what's in there. And other components get into our brains and body, and we get defended from it. But slowly and surely, these bug components, one of them is called lipopolysaccharide, LPS, gets into the brain, as well as many other proteins, and produces a very low-level inflammation. It's not like you've cut your skin or bruised your body. It's a much lower, sort of more subtle degree of inflammation. And that's what I reproduce. Using LPS, the same thing the bugs in our bodies are releasing into us, 24 hours a day, 7 days a week for about 4 months, 5 months. We slowly infuse it into the brains of the animals at different ages, different genders, that kind of thing. And then at the end of those 4 weeks, we sacrifice the animals, look at their brains, and we can stain them. We can study the histology and pathology and see the inflammation there. It's very easy to identify. And that inflammation in a human brain, day after day, week, month, year after year, decade after decade, slowly impairs brain function. And it leads to conditions like Alzheimer's or Parkinson's or ALS. It depends on what your genetic makeup is in terms of what you get, or maybe your lifestyle. But in general, it's just being alive every day. This happens. It's guaranteed. If you live long enough, you have brain inflammation, very low level. And now, what else did you do in your life? Did you drink a lot of beer, smoke cigarettes, those kinds of things, smoke marijuana in your 20s and 30s and 40s? Things change. So the approach now with our animal models is that we reproduce that low-level, long-term chronic brain inflammation that seems to underlie a normal person's 40s to 60s to 80s. And then what we do is we give them the marijuana equivalent of one puff in terms of the number of molecules that we put into their body every day.
Yeah.
And then essentially we're slowly bathing the brain with a few molecules every day. So I would do the same thing if it was caffeine, or if it was one of these experimental compounds, or if it was ibuprofen. We've even done that kind of thing because, why not try just a basic anti-inflammatory? But anything that you do that reduces brain inflammation seems to slow the aging process. And there are many ways of doing that. Eating colorful fruits and vegetables, drinking all that coffee, puffing a marijuana puff every day. And everyone seems to have chosen a different approach. And we meet them at the end of their lives and they tell us their story. Well, I drank a lot of this, I ate a lot of that, I smoked this. And then we work backwards and say, oh, well, in my model, this is what I reproduced of what you did. And this is why I think it worked for you.
So I would love to press rewind to an earlier point in our conversation where it sounded as if you were advising against exercise because obviously you're breathing heavier and you're needing to eat more to support the caloric requirements for exercise and things like that. And I felt my own hackles go up at that point. And I'm sure probably a lot of people listening might feel the same thing and say, everything this guy's saying sounds smart, but I don't necessarily want to take his word for it that exercising isn't a good thing for my long-term longevity. Can you riff on that a bit?
Oh, my pleasure. I get that question more often. I always like to walk up to the edge of that precipice and let people decide if they want to go off.
Right.
It's fascinating because it does follow from what I'm saying. If you take two individuals who are genetically identical, living identical lives, and you have one of them take in, 1,500 calories a day, and let's just move around and they're doing nothing special. And you have another person who is a marathon runner or one of my swimmers who swims 4 or 5 hours a day, and ask the question, who is aging faster? The answer is very easy to answer. The person who consumes the most carbon bonds ages faster. They die sooner, of all things.
Wow.
It's a given. And if you talk to people who exercise, look at joggers. Talk to some of them. They are addicted to jogging because of the endogenous opiates that come. They love that high. But you have to ask yourself, why would your body release an endogenous painkiller? You have just induced pain and injury. Your body's going, you idiot, what have you done to me? Here's some opiate. Please don't do that again. And then you go out and do it again and again and again, and your ankles hurt, your feet hurt, your knees hurt. Find a jogger who isn't in chronic inflammatory joint pain, and it's going to get worse and worse.
Since the brain is 2.5 or 3 pounds out of however many pounds you weigh, and your caloric requirements are to cover the needs of your entire body, I'm wondering if a person who is wanting to maintain an athletic physique and have to eat some more food as a result of it, yes, they're getting more oxidative damage, I guess, from eating more food, but that's sort of distributed across their entire body.
And one of the things I do in my most recent book, The Brain, What Everyone Needs to Know, I deal with that at the very beginning. First of all, the first question is, why is our brain in our head, not safely ensconced in our chest or body? But the second one is, who gets all the energy? It turns out that it kind of follows the genome in a way. If you ask the question, what parts of my body are the most active genetically, the most active energetically, and what we find is that that's who gets the most energy. So our brains have two purposes. One, keep you alive as an individual so that you can do two, procreate, to make more of you. That's it. That's all our brains need to be there for. Stay alive, make more brains, or I like to call it make more feeding tubes. The other thing is procreation. So as our brains got bigger, we lost procreation ability. We give birth not to litters, but of ones or twos. When you have a big, expensive brain, that's the trade-off. Our guts are as long as we can get them to stuff them inside of us, and they're as efficient as we can make them. So who gets all the oxygen and all the nutrients first and gets most of the blood flow out of your heart? Brain. After that, you've got to give the energy to your gonads, because it's all about you staying alive, you avoiding ending up in somebody else's feeding tube, and your job is to make more of you. So if you put it in terms of why do we even have a brain, then it makes sense of where all the energy goes. So yes, you do have a big body, but in terms of the amount of energy devoted to muscles and stuff, it's a small percentage. The muscles themselves for most people don't take up enough mass, energetic mass. Now, if you want to go jogging long distances, you can shift that balance. And if you start burning up more and more, you're going to mess up other organs. All right. For example, women who jog long distances stop menstruating sometimes when their body fat becomes so very low. We know that people when their body fat becomes so low, are more likely to become depressed. And part of that depression is because of all the inflammation from the exercising actually causes them to become depressed, which makes them crave more long distance jogging to get that dose of endorphins to treat their own induced depression. We're addicted to the exercise. It's just what our body does to protect you. So when you ask yourself, where's all that energy going that I'm taking into my body? Is it just being absorbed by other tissues? The answer is not that much. Fat doesn't use a lot of energy, and your muscles don't make up enough energy for most of us. And most bodybuilders are not going to be joggers anyway, so they're kind of distorted. But for most of us, it's all about the brain. We also know there's the other connection of don't exercise and living a long time. One of my favorite ones is the guy who runs the TV show, The Biggest Loser. They love watching big people exercise. But he had an interview, I think it was last year, and he said when he first started the show, he said it was all about the exercising and not so much the diet. But then he realized it has nothing to do with the exercise. It's all about not eating. If you want to lose weight, it's, oh my goodness, it's so very simple to say, but impossible to do. Stop eating. If you're going to stop eating, you'd better stop moving so much. So we get to the point, if you take my comments to the extreme, that you're not going to move around, you're going to eat 900 calories a day, your bones will become brittle and disappear, your muscles will atrophy, and you will be a quivering mass of skin that can barely change the TV channel from the couch.
Right.
Nobody wants that life. So it ends up being a competition of forces. Where's the happy medium here? You must do weight-bearing exercises on a planet with gravity, otherwise your bones will become brittle and lose calcium. We see that with our astronauts. You must do aerobic exercising for your cardiovascular system, but you're going to pay for it. Every time you burn up more oxygen and breathe heavily, you are simply slowly aging your body. We live on a planet where every organism gets its energy from carbon bonds. One day, 4.5 billion years ago, some organism said, hey, there's some oxygen here. We can use it to get rid of our carbon debris. So we gobble in carbon bonds, eat a little of the energy between them, and we're left with carbon debris. We bring in oxygen and blow off CO2. And that's all we do. The less O you have to bring in, the slower you age. The purpose of hemoglobin is to keep the oxygen level in our bodies low enough so that we don't outright kill every cell. Oxygen is so toxic to us. That's why we're covered in dead skin and mucus. Every part of you is covered in either dead skin or mucus to keep the oxygen out of you.
I can switch back to cannabinoids for just a moment. The one question that has been lingering for me, we have endocannabinoids. We have very close analogous molecules within our bodies. Why focus on exogenous sources rather than maybe try to somehow uptick our own endogenous production?
Actually, that's a great point. And some of the drugs that I've been working with most recently from a French drug company are doing exactly that. In fact, the way that the endocannabinoid, that molecule in your brain that you make, is inactivated, one of the ways is by what we call reuptake, where it's like vacuumed up into a neuron and therefore it stops acting in the brain. Well, this company invented a drug that is capable of preventing that reuptake. So this is kind of what it might be like, this scenario. You pop this pill in the morning and nothing happens to you. And then you're driving to work or you're sitting listening or you're watching a movie and you laugh. Or maybe you pick up your child and you have this nice warm fuzzy oxytocin-like feeling and you go, wow, that was funny. And then it builds a little more and you go, oh my goodness sakes, this is really funny. I feel really happy now. And then it moves into a full-blown high and then it keeps augmenting more and more of your own endogenous cannabinoids, preventing them from being inactivated, and you release more because you're happier. And it's just this positive feedback cascade until you are full-blown hallucinating high. Then we don't know what happens because the company hasn't figured out how to turn it off yet. You have to wait for the drug to wear off, and you better hope you weren't listening to a radio show when you started laughing. But you can see where we're going. They're going to have to figure out a way. You pop another pill that says, okay, turn it off now, because it might last 4 hours, 6 hours, but they could tweak that. They could say, look, in the next 4 hours, try and find something funny. It's going to be amazing. And it will be as high as your brain is capable of becoming, because every single cannabinoid receptor, in theory, will be affected by their drug. Now, what that would feel like to a human is anyone's guess. My assumption is they've never given it to a human. I've given it to rats. I don't know what it's like to be that happy if you're a rat, but it must be amazing.
Based on everything that you know, what is your own eating/exercise physiology regimen like?
You know what? That's interesting too. I am a vegetarian. I don't eat very little red meat. I get it from other sources. I like vegetables more and I eat a lot of fruits and some grains. And there's one thing though, it's not as simple as I've laid it out. The way I've laid it out to you is that we're a blast furnace. Take in energy, burn it up with oxygen, get byproducts, age. It's more complicated than that, it turns out. We live on a planet that is rotating in front of a sun. And those rhythms, that biorhythm, was part of the evolution of single-cell, multi-cell organisms. It plays a huge role. And in the past few years, what we've discovered is that if you take people and have them eat 2,000 calorie a day diet, that classic thing, and you have them put, say, 1,500, 1,600 calories that they eat completely for breakfast and dinner. In fact, have them eat 1,000 for breakfast. Big breakfasts. Definitely not your American approach. What we find is that those people who push in most of their calories at the beginning of their biorhythm, they gain less weight, they're healthier, and they have less insulin resistance. So biorhythms are just as important as what and how much you're eating. Yeah. And I think that was a huge surprise. So if you take a different person, 2,000 calorie a day, and you give them the American approach where they put in 1,000 to 1,200 because they've skipped breakfast, they're going to be hungry all day long, and they're going to eat big meals and then go to sleep and gain weight. So what I try and do is finish all my eating by 4 o'clock, 4:35 at the latest. Yeah. And then don't eat again, because what we've also discovered is that overnight fast does modify a person's physiology. So if you don't eat from 5 a.m. until 7 a.m. the next day, we're talking 14 hours of fasting. That helps you lose weight too. Mm-hmm. So it's not perfectly linear. It isn't just the number of calories. It is also when you're taking them in.
I would love to do a tag team interview on you and Dr. Dr. Mark Matson from the National Institute on Aging. It sounds like you would agree just down to the letter on some things, but on other things you might have really sparks fly.
Sure. Mark loves jogging, though. Mark has contributed much to this literature. Oh, my God, if there's a pioneer in the field, it would have to be him. And I don't know if you've ever met him, but he's very thin.
Yeah, I interviewed him a couple of months ago, I think twice now. And yeah, I think he's fantastic.
And I think he's also made some interesting discoveries lately in terms of some of this stuff about caloric restriction went too far. And he corrected some of that. People were saying, oh, you're going to live a lot longer, and everyone was getting on that. And I think he demonstrated beautifully that there's more to it than that. You can live maybe longer, healthier for the years you have, but you're not going to live to 120 or 30, which is what we were kind of misled in the 1980s and 90s from our animal studies, because we had bizarre animals. They were living in cages. They were inbreds. It wasn't right. It wasn't good models. Our discoveries are only as good as our models. And when the models sometimes are not well designed, we don't find the truth. Even with primates, I used to work with them when I was at Johns Hopkins, and my goodness, it's so expensive, to do those studies. We need it on humans, but who's willing to do this is the problem. The people we put in the biosphere out in Arizona, we saw what happened to them, with their health. And you can see easily how efficient caloric restriction is at losing weight as compared to exercising.
Right.
And every January, everybody who buys a gym membership and puts on a little 5 pounds of muscle weight and then gives up by March knows that same experience. But no one ever listens to me. My TED Talk was essentially breakfast like a king, lunch like a prince, and dinner like a pauper. But what restaurant's ever going to put a sign out? Come on in, sit down, and eat nothing. I think Mark and I would agree that it's a way to save money.
And he's very big on the intermittent fasting also. I mean, I've adopted that in my own life, but I must admit I've pushed it to the later part of the day just because I feel like my brain is a little bit more peppy with no food in my belly, and I like to get my mental work done early in the day.
The studies that have been done show that Mark is right. Intermittent fasting does work, but so does the daily fasting. Seems to be almost as effective. And for me, I couldn't do the every other day stuff that he does.
Oh, you're talking alternate day fasting where it's one day on, one day off. Yeah, that's hardcore.
Oh, God, is it? And from the animal studies, again, it's just animal studies. It doesn't seem like it's entirely necessary. But he's gotten used to it. He was doing that 30 years ago. He's gotten to the point where he can tolerate it. I just couldn't do it.
Smart Drug Smarts.
So thank you so very, very much to Dr. Gary Wenk for taking the time for that conversation. That was one I felt was truly interesting. I'm looking forward to reading Gary Wenk's book when it comes out here. The title of that one is The Brain, What Everyone Needs to Know, and that's going to be out on March 1st of this year, so just around the corner. It's always kind of fun when the conversation goes in a direction that I don't expect. I wasn't thinking that we were going to be slinging bombshells at the idea of getting exercise as something that's increasing oxidative stress and accelerating aging, and kind of not the news that as a longtime exerciser I wanted to hear. I definitely felt myself cringe and still kind of feel myself cringe as I think about that. But I think probably one of the themes of these sorts of studies into personal optimization is that there's just not a way of doing life perfect. There's always going to be trade-offs and checks and balances. And despite the best of intentions, I don't think we're ever going to find the one true path. And although I could certainly see people who aren't big exercisers using what he said there as an excuse to not pick up that exercise habit, I think the potential consequences of taking those ideas to their logical extreme and really being a sedentary, lethargic sort of person, that's not going to have the right outcomes either. So we got to pick our way across these lifestyle minefields carefully. But all that said, let's get Valentine's again for one last little flourish in the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
So when people are asked to justify in words what it is that they love about the people that they love, one of the things that you typically hear is, my girlfriend or boyfriend or husband or wife really understands me. That's kind of like a safe fallback phrase that almost always comes out when people are listing the good qualities of a loved one. But a recent study conducted by scientists at the University of Lübeck and published in the Proceedings of the National Academy of Sciences actually shows something that, while it doesn't contradict that idea that we're attracted to people who understand us, it actually seems to show and reinforce the mirror image of that, which is that we might be attracted to people who we feel that we correctly understand, and not necessarily understand in a cognitive rational way, but understand their emotional states, says the study's author Silke Anders. Being able to comprehend another person's intentions and emotions is essential for successful social interaction. Partners must understand and continuously update information about their partner's current intentions and motivation, anticipate the other's behavior, and adapt their own behavior accordingly. Anders and her fellow researchers wanted to conduct a study to see if there was a neural mechanism that might connect one person's ability to read the emotions of somebody else and whether that might have an interplay with an attraction between the two people. They got video clips of women who facially expressed either fear or sadness, and then they had around 90 people watch these videos and rate in each case what they thought the woman was feeling and how confident they felt in their assessment. So I watched the video, I say, that woman's scared, and I'm 85% confident that she actually is scared. Then after watching these videos, they also asked the people how attracted they felt to the actress that they were watching. And it turned out that those two were tightly correlated. The more a person felt that they could correctly assess the actress's emotion, the more attracted they felt to that actress. These questionnaire-based assessments were also backed up by what the researchers saw when they looked at the participants' brains. Higher levels of certainty and attraction were associated with more activity in an area of the brain that processes rewards. As Anders explains, if the emotional signal sent by a sender, for example, a facial expression of fear or sadness, can efficiently be processed by the perceiver's brain, the reward system will fire and they will feel attracted to the person displaying the emotion. So in a way, that old saying, to know him is to love him, when it comes to knowing a person's emotions, that might be true for just about everybody.
We like to think of ourselves as a digital speakeasy for brain hackers, but you can call us Smart Drug Smarts.
Okay, you made it to the very end of the episode. Thank you for hanging around with us. If you enjoyed this episode, you will find the links to everything that we talked about here online at smartdrugsmarts.com/168. If you missed last week's episode, I spoke with Dr. Beverly Meyer about passion flower, the neurotransmitter GABA, and some other herbs and natural ways of mellowing oneself out. Next week in 169, I'm not going to tip my hand just yet because there's a couple of things that might be coming up. A little biometric tracking, a little looking at the ways that various kinds of light affect our brains, and a couple of conversations about the drugs modafinil, armodafinil, and adrafinil all coming down the pike. I'm not exactly sure what order those are going to land in, though, so you'll just have to check back here next week. Last little plug if you haven't done so yet, smartdrugsmarts.com/newsletter to get yourself those brain breakfasts in your inbox. But I'll see you back here next Friday, same time, same podcast, and with the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.